So the question says, find the nth term of the sequence -3, 5, 19, 39. So we work out the first difference, so that's 5 minus -3, which is 5 plus 3, which is 8. And then 19 minus 5, which is 14, 39 minus 19, which is 20. You see again that the first difference is not the same, and so we know that this is not a linear sequence. And so we work out the second difference now, so that's 14 take away 8, which is 6, and 20 take away 14, which is 6. Because the second difference is the same, we can now write that 2a equals to 6, where a is the coefficient of n squared. And so solving this equation, we have a equals to 3. Therefore, the nth term of this sequence can now be written as 3n squared plus bn plus c. And so we now take away 3n squared so that we're left with a linear sequence. Now the first term in 3n squared is equal to 3 because 1 times 1 is 1 times 3 is 3. The second term would be 2 times 2, which is 4, times 3, which is 12. The third term would be 3 times 3, which is 9, times 3, which is 27. And the fourth term would be 4 times 4, which is 16, times 3, which is 48. And we're subtracting this sequence. So we now have -3 minus 3, which is -6, 5 minus 12, which is -7, 19 minus 27, which is -8, and 39 minus 48, which is -9. And the nth term of this sequence is bn plus c. As we have a linear sequence now, the first difference should be the same. And so let's work out the first difference. So that's -7 minus -6, which would be -7 plus 6, which equals to -1. And then the next term would be -8 minus -7, which is -8 plus 7, which is -1. And then -9 minus -8, which is -9 plus 8, which is -1. And so because the first difference is the same and this is a linear sequence, then we have that b equals to -1. So the nth term of this sequence would now be -n plus c, because we've replaced b with -1. We add on the sequence n so that we end up with c on its own, because -n plus n would cancel out. So writing the sequence for n, we have the first term, which is just 1, the second term, which is just 2, the third term, which is just 3, and the fourth term, which is just 4. So adding the two sequences together, we now end up with the following. So that's -6 plus 1, which is -5, -7 plus 2, which is -5, -8 plus 3, which is -5, and -9 plus 4, which is -5. And this equals to c. And so with c being equal to -5, we now have the value of a, b, and c. General form for the nth term of a quadratic sequence is given by an squared plus bn plus c. And so substituting in our values for a, b, and c, we end up with 3n squared minus n minus 5. And that is the nth term of the sequence -3, 5, 19, 39. So we can check the nth term of our quadratic sequence by labeling in the term numbers. So when n is equal to 1, we should get -3. When n is equal to 2, we should get 5. When n is equal to 3, we should get 19. And when n is equal to 4, we should get 39. Check n equals to 1. So substituting n equals to 1 into our nth term, we have 3 times 1 squared minus 1 minus 5, which simplifies to, so 1 squared is 1, times 3 is 3, minus 1 minus 5, and so 3 minus 1 is 2, and 2 minus 5 is -3. So indeed the first term is equal to -3. Likewise, we can check any of the other terms and it would satisfy this nth term. Final example, we have that find the nth term of the sequence 0, -3, -8, -15, -24. Again, we work out the first difference, so that's -3 minus 0, which is -3, and then we have -8 minus -3, which is -8 plus 3, which is equal to -5, and then -15 minus -8, which is -15 plus 8, which is equal to -7, and then finally we have -24 minus -15, which is -24 plus 15, which is equal to -9. See that the first difference is not the same, and so we now work out the second difference. So that's -5 minus -3, which is -5 plus 3, which is equal to -2, and then we have -7 minus -5, which is -7 plus 5, which is equal to -2, and then -9 minus -7, which is -9 plus 7, which is equal to minus 2. And so because the second difference is the same, we have a quadratic sequence. Just as a little extra, if the second difference was not the same, but the third difference was the same, then we would have a cubic sequence, and so on. Because the second difference is equal to minus 2, then we have that 2a equals to minus 2, and so solving this equation gives us a equals to minus 1. And so the nth term of the sequence can now be written as minus n squared plus bn plus c. So to work out the value of b and c, we now add n squared. First term in n squared is equal to 1 because 1 squared is 1. The second term is equal to 4 because 2 squared is 4. Third term is equal to 9 because 3 squared is 9. Fourth term is equal to 16 because 4 squared is 16. And the fifth term is equal to 25 because 5 squared is 25. Now we're adding this sequence because we want to cancel out the n squares. And so 0 plus 1 gives us 1, minus 3 plus 4 gives us 1, minus 8 plus 9 gives us 1, minus 15 plus 16 gives us 1, and minus 24 plus 25 gives us 1. Nth term of this sequence is bn plus c. So if we wanted to work out the value of b, we would then work out the first difference, which we find is equal to 0. And so therefore, the value of b is equal to 0, which means that c must equal to 1, because these terms are constant. Finally, comparing with the general form for the nth term of a quadratic sequence, we have an squared plus bn plus c, and so substituting in our values for a, b, and c, we end up with minus n squared plus 0 times n plus 1. And so if we simplify this, we end up with minus n squared plus 1, which is the nth term of this sequence. So as a final check for the nth term of this sequence, we know that when n equals to 1, we should end up with 0. When n equals to 2, we should end up with minus 3. When n equals to 3, we should end up with minus 8, and so on. And so using the nth term and any of these values of n, let's use n equals to 3 to check that the third term is indeed equal to minus 8. So if we substitute 3 in, we end up with minus 3 squared plus 1. And so this simplifies to 3 squared first, which is 9, and the 9 times minus 1, which is minus 9, plus 1, which then simplifies to minus 8. And so we see that the third term is indeed equal to minus 8. And so that is how you work out the nth term of a quadratic sequence.